Okay, so I actually want to just spend 10 minutes getting you to think a little bit about how we're going to make our energy going forward. And I guess in doing that, I'm going to tell you about some novel solar cells that we're making at Flinders, tell you a little bit about how we make those and why we think it's an exciting development. So here's a map of the world at night, and of course there are lots of bright dots on it because everybody's turned on their lights to make sure that they can see and don't run into the walls and stuff at home. But of course we are now confronted with some significant issues about how we generate our energy. One of them, of course, is the simple fact that lots of our energy is generated with things that look like that. And of course we've just introduced a carbon tax here in Australia to try to stop people from making their energy like that. Okay? But look, let's not gloss over the fact that this is cheap. We all use it because it's cheap. Another thing you may or may not realize is that the lights here are almost certainly powered by electricity that comes from Torrens Island, which is, 30 k's away from here? So one of the current issues in our energy system, and Andrew mentioned this, okay, is about 25% of the electricity produced never gets used for anything. So we have this distributed system, we make electricity and we send it down this line, and only about 3/4 of that turns into do anything. So clearly, if we're going to get much, much more efficient, we actually probably want to get to a system where we produce the energy or the power we need very close to where we want to use it. Okay? The last point I'll make about energy is, energy drives more or less everything that happens. There's a really interesting paper that was written by a guy named Rick Smalley, who won the Nobel Prize about 6 years ago. And in that paper, he defines all the problems of the world. And basically, what he argues is that if we had cheap, reliable energy, we can solve them all. But of course, we don't have cheap, reliable energy, and we especially don't have it in the third world and in other places. So that's a problem we've got to solve. Okay, so let's think about how we're going to make our energy going forward. Right now, we make our energy with fossil fuels almost exclusively. So all those renewable things where we hand on our hearts and we say, yes, they're fantastic, okay, they're in the noise. Okay, we might like to think, we're doing the right thing. It's in the noise. But there are lots of possibilities. There's waves, Andrew mentioned that. There's biofuels, we mentioned that. There's wind. South Australia has a huge wind production capability, so it's a really nice idea. There's, of course, nuclear power. But the thing, in Australia, okay, really, if we're going to produce power, we really are thinking about using the sun. Okay, if you lived in England, you wouldn't use the sun. Okay, it comes out 3 days a year. In Australia, we have some sun, so we can take advantage of that, hopefully. So how are we going to do that? Well, I'm curious now, show of hands, how many people have solar panels on their house now? Okay. And you paid, I'm guessing, especially if you did it in the last 18 months, $2,000 to $3,000. And of course, the real price of those solar panels is something like $12,000, but of course the government, gives somebody $10,000. I've never quite figured out where that $10,000 go, I have to say. But so the price of the solar cells that you're putting on your house right now is about $12,000. That's for a 1.5 kilowatt system. And if my house is a typical house, that's about 25% of the power that we use on average. Okay, so it costs you about $12,000 to produce about 25% of the power you need. Clearly, and Andrew made this point, nobody, I don't think, out there is probably going to roll out $50,000 to power their own house. And right now, that's basically what you'd be looking at. So in Australia, we should think about using the sun to make our energy, to make our power. And there's several ways to do that, but the way I want to talk about is photovoltaics. And so the things on your house are photovoltaics. And essentially what they do is some light impinges on something. Okay, it creates some electricity, and that electricity goes off to, right now, of course, it goes off to the grid, or potentially, of course, it just goes into your house and turns on the blender. The problem with the current cells, okay, is that they use silicon. And the silicon they use has to be very, very, very pure, And to purify silicon, it has to be heated to a couple of thousand degrees, cooled back down, heated up, cool back down, heated up, cool back down several times. So they're energetically very, very expensive to make. And that means it actually takes you quite a long time to get back the energy you used to make the thing in the first place. Okay, so it's great that you're putting them on your houses. Okay, and there have been huge advances in that area. I have to say, the time it used to take to get the energy back probably 5 or 6 years ago was 10 years. Now that number is a few years. So there have been huge advances in that area. But it still takes several years to get back the power. So what we're doing at Flinders is we're using a material called carbon nanotubes to make a different type of solar cell. And I've brought a carbon nanotube with me today. Well, okay, this is not it's a model of a nanotube, okay? If they were this big, boy, they'd be easy to work with. So this is a new material, okay? They're called carbon nanotubes. Guess what they're made of? Oh, okay. They're made of carbon. That's good. Carbon's cheap. Okay? It's a tube. Okay? And you can pull the end off, and it really would look like a tube. If you pull the end off, though, the model is nowhere near as nice to walk around. So why are these things special? It's a material that was discovered about 20 years ago. Okay, why are they special? Well, one of the reasons they're special is that they're incredibly strong. Okay, some of the strongest material ever discovered. Another reason they're very special is because they conduct electrons, they conduct electricity better than any material ever discovered before. So basically what that means is if I put electricity in this end, okay, all that electricity will appear at this end. I won't lose anything. Okay. The other good news, bad news story about a carbon nanotubes is that they are as reactive as dirt. Okay, well, in fact, they're not even as reactive as dirt. They're not very reactive at all. And if you're a chemist, that's not a good thing. Okay, so my group has probably spent the last 5 or 6 years learning how to play with these things, being able to connect them to other things, okay, being able to put them where we want them to go, okay, being able to dissolve them so that we can process them. Okay, and all those abilities mean that we can make these solar cells. And I have a couple here. I'll give these out so people can have a look. But it's a very, very simple architecture. Okay, we just make it in a lab in a beaker. Okay, so we're not heating and cooling silicon down up to thousands and thousands of degrees. And the advantage of that is it's very, very simple to scale up this. Okay, this is not going to power your house, I should point out. Okay, but it's very simple then to scale this up into a commercial process. Whoa. So I'll let people hand those around if you want to have a look. So it's a very, very simple device, easy to make in the lab. And if you make it right, and I'm lucky enough to have some very talented students, okay, they don't let me in the lab because I'd hurt myself, but my students are very talented, and we can make solar cells now that have an efficiency of about 7%. Now the cells on your house have an efficiency of about, let's say between 15 and 20%, depending on what the birds have done on them and which way the sun is shining and a whole pile of other things. Okay? So the question is, why would 7% be better than 20%? Well, because, okay, of the ease of manufacture of these. Okay, and the things I'm handing around are very small, but the simple reality is making them very big is not at all a change in the process, and hence getting to something where we can have a commercial outcome is actually very straightforward. So what do we want to do? Well, this is a picture of the house that maybe you live in right now, and somebody described what's happening right now as putting a roof on the roof of your house. Okay, and that kind of seems like, I'm not sure that that's such a good use of our time. So what we really want to do is we want to go from this to something that looks like this. And in fact, what we hope to do is basically get your house to look exactly like your house. And the nanotube filament I'm talking about is very, very thin. Okay, because it's so efficient, if we made this on your windows, okay, you wouldn't even know it was there, and yet your windows would now be producing the electricity you need in your house. The other alternative is you could just spray it onto the roof, and again, it's very thin. You wouldn't even know it was there. Okay? So where are we now? Basically, we want to take the things that are being passed around, we want to make those many, many times on the same substrate. So what you want to do here is make multiple places that you can harvest the energy, all on a single space. Okay? And to do that, we need people who can help pattern the substrates and then do the deposition in a very straightforward way, just out of solution, which is what we currently do. So thanks for your attention. I'll leave it there. Thanks, Paul.